So, this is the very last presentation of the day, and this has at least two advantages. The first that is that there are only very disciplined people in that room. Yes, and thank you very much for being here still. The second is that being the last means that I have already heard all previous speakers, so I can take advantage of this and present something that can look as a summary of the day. So, okay. The objectives of the presentation is to provide a framework for classifying CO2 reducing measures and policies as they have been proposed for the shipping industry, and to draw recommendations on ship economy, energy, and emissions. The next 20-25 minutes, I will talk about these topics there, sustainability frameworks, a little bit about it. Then how we can decompose the CO2 emissions and create the framework for classifying the reduction measures. And I will close with a few conclusions. So, sustainability frameworks. If you go through the literature, you'll find a number of different types of frameworks used for monitoring sustainability. But what you see there is a real nice and concise typology. Basically, it consists of three categories. The first focuses on the impacts of the actions that are undertaken or proposed to improve sustainability, and usually they contain indicators referring to the three pillars of sustainability: economy, environment, society, the so-called tripartite framework or triple bottom line framework. Then the next category goes one step further, and in addition to impacts, it also looks into the causal factors and corrective actions. The pressure, state, and response is one of these frameworks. We will discuss it in a while. That's why it is marked in red. And then the last one refers to a specific organization, and it looks into the possibilities that this organization has to affect the sustainability. So it includes indicators that have to do with the condition, the state of the environment, the behavior of the stakeholders, and the operations of the institution itself. Now, for this presentation today, we have no institution, specific institution in mind, and we also need the causal factors, corrective actions. So we have to look into this linkages-based group of frameworks. And here is the pressure, state, and response, how it works. Basically, yes, the human activities exert pressures on the environment and affect the state of the environment. And then the society responds by actions to prevent the negative impact, which in turn affect the human activities. Now, one particular type of this kind of framework is this one, which is called Criterion Influences Actions and Measures. Basically, it consists of these four steps: select a criterion, which in our case is the CO2 emissions, then deconstruct the criterion into a number of influences, and based on these influences, we identify actions and then policies that facilitate these actions. So, and this brings us to the decomposition of the CO2 emissions, which is our criterion. Now, back in 1990, this Japanese researcher, Yoichi Kaya, introduced what is known as decomposition analysis. he expressed the CO2 emissions as a product of 4 factors, the ones that you see there. The first one is the carbon intensity of the energy, is CO2 produced per energy unit consumed, and basically has to do with the mix, the fuel mix that is being used. The second one is the energy intensity of the economy, is energy units consumed per GDP. The third one is the GDP per capita and the global population. Now, as you can imagine, this identity can be easily transformed to express other interests. Young in 2009 used a very similar decomposition formula to express CO2 and take into consideration transport. So he replaced the energy intensity of the economy with the energy intensity of transport. Here, you see? And here is our use of this identity. Basically, we replace the population, we drop the population from the identity because we think that it is beyond the scope of this analysis, and we wanted to introduce the vehicle kilometers. So this is what we are doing here. We have 5 terms. The carbon intensity, mg is energy, it's megajoules. This is the energy efficiency of the vessels, energy per vehicle kilometer traveled. And then here is strange ratio. This is basically how many vehicle kilometers we need to transport a specific number of ton kilometers. And then tons lifted and the average distance of the whole. Now this factor here can become better if we take the inverse of this. And now this is the ton kilometers produced by one vehicle kilometer, which can also be expressed by these 2 factors. Here is the capacity of the vessel and the capacity utilization rate. So now if we add summation factors for fuel and vessels, we have our formula. And this is the framework that we're going to use for classifying the CO2 emissions. Okay. Let's start with the first factor, carbon intensity. I don't know if any of you were yesterday at another event of the Danish Maritime Days at the Danish Ship Owners Association. There was an event on disruptive innovations. And basically what they said is that the most important disruptive innovations are alternative fuels. And these are the alternative fuels that have been proposed for shipping: LPG, natural gas either in liquefied or compressed form, electricity, biofuels, hydrogen, wind power, and solar. Of course, the last 2 are in the experimental phase, with the exception of the towing kites that have reached the market already. Then let's move to the energy efficiency of the vessels. There is a number of technologies that can be employed here. And we start with the ship design, optimization of the hull in terms of the basic ship particulars, capacity, design, speed, dimensions. When we draw the lines of the vessel, we minimize the resistance, and of course we take into consideration the EEDI, Energy Efficiency Design Index, which sets the standards. Also at the design level, we define the propellers that we're going to use and other propulsion improving devices, including air lubrication, which is still in the experimental phase as well. Then, of course, we can play with the construction material, high tensile steel, as an example, and a long list of technologies that involve the main engine and the auxiliary engines of the ship. Fuel ignition, the timing of the valves, exhaust valves, the turbocharger, the lubrication of the cylinders. I mean, all kinds of technologies. Exhaust gas heat recovery systems, shaft generators, variable speed motors, etc., etc. But it's not only technological measures. And what can be more important is operational measures, and we have heard quite a few of them since this morning. Voyage speed optimization, basically we're talking about slow steaming or virtual arrival or schemes like that. Weather routing, optimization of the route of a ship, taking into consideration the winds, the waves, the currents. Trim and draft optimization. We need to keep the hull and the propellers clean, of course. MRV, monitoring, reporting, and verification of CO2 emissions and fuels consumed. The SEMP, the Ship Energy Efficiency Management Plan. Okay. Then we're talking about the capacity and the utilization of the vessels. Basically here what it says is that the larger the vessel, the lowest the emissions are, ceteris paribus, meaning the other parameters being equal. And the same applies for the utilization ratio. What we can do here other than increasing the capacity of the ship, of course, is selecting the optimal size of a vessel for a particular trade, to improve the flexibility of the vessel basically through the cargo handling equipment. Optimal cargo mix, it was mentioned by Mai this afternoon. Cargo consolidation, hub and spoke networks, we heard David this morning talking about it. Green corridors, which is another way of consolidating cargoes along specific corridors. And of course, the well-known alliances, collaborative business strategies, vessel sharing, and exchanges of slot. So what I wanted to tell you is that I deliberately used both these factors in the same box because it makes no sense to have larger vessels if they sail empty. So, and there are a number of very good articles in the literature that really connect these two factors together. So the larger the vessels, the container ships get, the more alliances we see. So, and then we're moving on with the transport demand, managing the demand. You see here 4 different ways to reduce the volume of cargo through miniaturization, which is what you see here. The size of the products is shrinking while the functionality of them is growing. Digitization with books, music, or entertainment industry. 3D printing, postponement. Postponement is what you see there, the adding value as late as possible in the distribution of the product, like adding water to the essence of a detergent or the essence of a soft drink as close to the market as possible, or bottling wine in Europe that is imported from South Africa, let's say, in tanks or things like that. And then when we are talking about minimizing distances, we are talking about restructuring the supply chains. And what you have in mind here is regional trade schemes, or moving production closer to the market, which is the opposite of the globalization. There's a number of people who are saying that we have already started seeing the first evidence of this trend, now that we're moving away from globalization. Okay, Now, in addition to having measures addressing each one of these factors separately, there are measures or policies that address a combination of such factors, and optimization of transport operations is one of them. Here, what you see, these four terms here, all taken all together, basically are equivalent of vehicle kilometers. So these are two very well-known families of problems that our colleagues, many colleagues in this department are working on. This traveling salesman problem and vehicle routing problem, which aim at minimizing cost or vehicle kilometers, depending on the formulation of the problem. So, and we have heard quite a few of those applications all day long today. The market-based measures is another family of policies that also involve a group of factors, and there are three types of them, targeting different entities. Here, the target is the vehicle kilometers. So we are talking about a scheme that addresses it's similar to a distance-based toll that is being used in Switzerland and Germany for trucks, where the operator has to pay a price per vehicle kilometer. Of course, in shipping, this hasn't been applied, although it has been proposed for inland waterways, but it hasn't been applied yet. The second type of MBMs target the energy consumed, and it can take the form of a tax or a fund or a levy on fossil fuel, or equivalently the offering of a tax rebate or a subsidy or a quota for renewable energy sources. And yet, the third MBM type addresses the emissions themselves. And this is where we're talking about internalization, full internalization of external costs, the ETS scheme, the emission trading system of Europe, and differentiated port use are examples of such schemes. And last but not least, we have shifts between vessels and companies, and of course between modes, but here in order to cover modes, we need another summation operator there over modes. We have already started seeing shippers associations who urge their members to select the providers, the service providers, based on the environmental performance of the companies, vessels and companies. So, conclusions. There is a wide range of measures and policies that reduce CO2. But the sustainability mobility, which is the target of the society today, sustainable mobility, yes, not sustainability alone, sustainable mobility is what we're looking for. And this is a very complex issue, and it requires the employment of packages of implementary measures rather than relying on single instruments or policies. Another thing that this formulation can help us with is to keep in mind that there are these push-down pop-up cases where when we try to intervene for improving a certain aspect, we see adverse effects, something else, through the substitution and income effects. Another interesting observation has to do with these win-win solutions. We have come to think that environment and economy are conflicting interests. But if we look at this formula, you see that all measures or actions or policies that target any one of these factors or any group of these factors end up with lower energy, and energy costs money. So all these activities reduce costs at the same time that they reduce emissions. So all of these activities are win-win solutions, and we should not overlook them. And finally, we have to keep in mind that shipping is only one transport mode. Efficient or environmentally friendly ships need efficient or environmentally friendly ports. And these need efficient trains, and these need efficient trucks. So it's the whole supply chain that matters at the end. And if we want to extend this line of thought, we can include production as well, and then we're talking about life cycle assessment. So thank you very much, and that was it.
Any questions for George? Maybe I can have one.
Please.
You haven't said anything about like the social effects. Are they completely irrelevant, like acceptance from people? Or do they not affect us at all?
Is there anybody in the society who wants more CO2? No. So everything that I have discussed is really desirable by the society. Yes. Sustainable mobility. Yes.
Anyone else?
Perhaps just a comment, not a question. I thought it was very interesting, but it's also a very big challenge we have ahead of us as the maritime industry, as a ship owner here, because we are to be zero emission within the next 50 years or so as an overall industry, if we are to comply with the global warming CO2 emission targets being set these days, this week, next week, and in the coming month. A lot is going to happen. So it's interesting to see formulas like this, and I fully agree with you. There are a number of options out there and levers to help us in this direction, but still it's also quite a challenge going forward. With trade going up at the same time, we have to reduce CO2 emissions drastically. But we will, at least from a Danish perspective, we will commit to these targets.
That's a very good point. I didn't have it here in the presentation, but I presented it 2 weeks ago when I defended my PhD. This year, last year, 2015, was the first year that the world CO2 emissions dropped while the world economy was growing. In the EU, this is becoming a trend, actually. It's been several years now that we have managed to drop our CO2 emissions. In the US, they have stabilized them. Even in China, in 2018, they managed to reduce their emissions. But there are other parts of the world, especially developing countries, like India, for example, where you see the line going up very, very rapidly. So, but overall, we have started making some progress, and it seems that the European society is really determined to do that. Actually, I was impressed last night to this event that I mentioned before. Although we know that MRV is in place, and we know that as of 1st of January of 2017, ship operators will have to count and monitor and report and everything. But it seems that the shipping community is under a lot of pressure for even faster reactions. I mean, they were discussing yesterday as if the IMO is going to take measures this week without even having to wait until 2018 when we'll have the results of the MRV. So I was really impressed by the pressure that the society is putting on the industry.
Indeed, they are under pressure, and it would be interesting to see what happens this week at the IMO. One obstacle that I see is politics. I mean, you mentioned India. I mean, we have India, China, Brazil, a set of developing countries. And for these countries, there is this principle of CBDR, which means common but differentiated responsibilities, which they say, well, we are developing, let us emit. And I mean, I've been to the IMO several times, and when they had the discussion on EDI, there was a very divisive discussion, mainly because of this CBDR. The market-based measures, the discussion was suspended because of CBDR. And CBDR is not only for the IMO, it is also for when they meet in Marrakesh in a couple of weeks. And my opinion is that unless CBDR is, destroyed or deleted somehow, you will never really see, progress. I don't know how they can do it, but they have to do something about it, because I think this is the main obstacle.
You're right. You're right. But China, you see that China has already changed
It seems that China is coming along. But
it's coming along. So if India follows them, then we are doing something right. I mean, the society at some point has to understand that it's our common future. Huh? This is a global thing. It's not national or regional. So the sooner everybody understands that, then the better it will be for all of us.
Can I add something? I mean, yesterday I was there also, and this guy, Henrik Madsen, former CEO of DNV, GL, mentioned that there is a discussion about a global tax, where they're going to collect money by putting a global tax on fuel, and this money they can use for all kinds of other things. I think this would be a good idea, but it is politically it's not a very easy thing to
no, it's not.
to pass.
It's not. But the civil aviation industry managed to do it very recently. So the same approach. So they agreed to create this fund, which will be used for green projects around the world. So something is expected, something similar is expected from the shipping industry, and I think that the ship owners, the ship operators themselves really have started wanting to do something about it. And, all right.
No more questions? Let's thank the speaker again.